Hi friends, welcome back to my YouTube channel. My name is Theorem. I am studying in Sri Venkateswara College of Engineering, third sem. Today we are going to discuss about engineering mathematics for CSE stream. In that we are going to discuss about sampling variable, central limit theorem, unveiling the power of sampling, a deep dive into the central limit theorem. Welcome. Today we will explore the fundamental concept of sampling variables and how to the central limit theorem empowers us to draw meaningful conclusion from data. Introduction to sampling. What is sampling? Sampling is a process of selecting a subset of individuals from a population to gain insight about me population as whole. Why sampling? Sampling is often necessary when studying large populations due to cost, time, and practicality constraint. It allows us to draw interface about the entire population without analyze every single individual. Population versus sample. Population. The entire group of individual or object we were interested in studying. It can be very large, even infinity. For example, all the people in a country or all the stars in the sky. Sample a smaller subset of the population that we actually collect data from its representative portion of the population used to make inference about whole group. Characteristics of sampling. Randomness. Each individual in the population has an equal chance of being selected for the sample. Representatives. The sample should reflect the characteristics of population for which it is drawn. Size. The sample size should be large enough to provide accurate and reliable results. Sampling distribution and central limit theorem. Respectively draw samplings from the population. Calculate the mean of each sample. The distribution of these sample means in the sampling distribution. Types of variables. Quantitative variables. Variables measured numerically. Example height, weight, age. Qualitative variables. Variable describing categories or characteristics. Example gender, color, type. Discrete variable. Variable that can only take whole number values. Example number of siblings, number of cars. Properties of sampling distribution mean the average of the mean samples mean will be equal to the population mean. Standard deviation. The standard deviation of the sampling distribution is called the standard error, which is smaller than the population standard deviation. Shape. Even even the population distribution is normal, sampling distribution will approach a normal distribution as the sample size increases. This is the essential of the central limit theorem. Properties of sampling distribution. Mean. The mean of sampling distribution is equal to the mean of the population. Standard deviation. The standard deviation of the sampling distribution is equal to the standard deviation of the population divided by the square root of the sample size. Estimating population parameters for simple data type. Point estimate. A single value the best represents the population parameter. Confidence interval. A range of values that is likely to contain the true population parameters. The confidence level is typically set at 95% or 99%. Importance of sampling size and the central limit theorem. Large sample size reduces variability in the sampling distribution. more accurate estimates closer to the true population parameters. Central limit theorem ensure the sampling distribution approaches normality. Implications of central limit theorem. First one, accuracy. It allows us to make more accurate inference about the population based on sample data. Confidence intervals. We can use the central limit theorem to construct confidence interval which provide a range of values where the population parameter is likely to fall. Hypothesis testing. The theorem is fundamental or hypothesis testing allows to determine whether the sample data supports or refutes a hypothesis about a population. Applying the central limit theorem in statistical interference. Hypothesis testing. Determining if there is enough evidence to reject a null hypothesis about the population. Confidence interval estimation. Estimation the range of values that is likely to contain the true population parameters. Statistical power. The probability of correctly rejecting false null hypothesis which is influenced by sample size. Practical applications of the theorem. Quality control. Monitoring production process to ensure consistent quality. Market research. Understanding consumer performance and predicting market trends. Clinical trials. Evaluating the efficiency of treatments and therapies. The central limit theorem. Key principle. The central limit theorem states the sampling distribution of mean will be approach a normal distribution as a distribution as the sample size increases regardless of the shape of the population distribution. Conclusion. The key takeaways. Power of sampling. The central limit theorem provides a powerful tool for making about populations. Conclusion. The central limit theorem is a crucial because it simplifies the analysis of the sample data. Even when the population is not normally distributed, the sample mean with a large enough sample size will be normally distributed, make it arise to apply statistically method that assume normality. The CLT conclusion is that large sample, the sampling distribution of the mean will approximate a normal distribution with a mean and standard deviation allows statisticians to perform interference as if data were normally distributed regardless of the population actual distribution. In summary, the central limit theorem enables us to make reliable statistical inference about population parameters using sample statistics even when we do not know the underlying population distribution, provided the sample size is sufficiently large. Thank you for watching.